Chapter 10, Think and Solve. A ball is thrown horizontally from a cliff at a speed of 10 meters per second. You predict that its speed 1 second later will be slightly greater than 14 meters per second. Your friend says it'll still be 10 meters per second. Show who is correct. All right, so once you throw it horizontally, it starts to get pulled by the force of gravity. Well, it's being pulled before you release it, but it starts to be affected by it because there's no normal force to hold it up. So once it's going, it now starts to fall. So after 1 second, the acceleration is downwards still. Once it leaves your hand, acceleration is downwards, which means its horizontal velocity doesn't change. So you still have that 10 meters per second horizontal component. But as it falls, it's gaining vertical velocity. So since acceleration is roughly 10 meters per second squared, then that means after 1 second, it's traveling 10 meters per second in the direction of acceleration downwards. So ultimately, the speed of the object is the magnitude of its velocity. After 1 second, it has a horizontal component of 10 meters per second, a vertical component of 10 meters per second. You add them together, you got a right triangle, little Pythagorean theorem. 10 squared plus 10 squared is 200. Take the square root of that, and you are at 14.1. It'll be closer to 14 if you use 9.8, I believe. And so you're right, not your friend, who I think in this textbook is wrong almost every single time, or close to it. In 27, you're in an airplane that flies horizontally with a speed of 1,000 kilometers per hour, 280 meters per second. When the engine falls off, ignore air resistance because that's what cool people do. And assume it takes 30 seconds for it to hit the ground. Show the airplane is 4.5 kilometers high. So this is, if you have an object and you drop it, it takes 30 seconds to fall. What is the distance that it fell? So because it's starting at rest, vertically it's starting at rest. Horizontally it has a velocity, but vertically it starts at rest and it just falls. We did the demonstration in class where I dropped a ball and I shot it at the same time. Let's see if I have the coordination to do this. So this one falls and that one falls like that. There we go. Close enough. So you're plugging into 1/2 AT squared. Since the acceleration is gravity, you can do 1/2 GT squared. This is a formula from chapter 3. Show the horizontal distance the aircraft moves is 8,400 meters. Well, it's traveling 280 meters per second, and it falls for 30 seconds. So that's just classic. Distance equals rate times time, because there's no acceleration horizontally. And so you have 280 meters per second times 30 seconds, and presumably that puts you around 8,400 meters. If the airplane somehow continues to fly as if nothing had happened, where's the engine relative to the airplane at the moment the engine hits the ground? It's right below it. Because as it flies, and again, coordination issue, the horizontal velocities are the same, and so it should be right over it at the same time. And that's it for the Think and Solve from Chapter 10.